Hello everyone, welcome back to the course on engineering graphics. This is the second lecture on section of solids and development of lateral surface. We are going to discuss about development of solid surfaces or development of lateral surfaces of the solids in this session. What is mean by development of lateral surface? It means that we will cut open the solid and unfold it so that we have everything on a single sheet as a single sheet. Okay, but in that case the solid is assumed to be hollow. It is not completely filled, so we have to consider that the solid is made up of sheet metal or maybe fabric or textile or any other material which is in the form of sheet. Okay, it can be even cardboard or thermocol sheet, whatever it is, but it is made up of sheet. So along those folds, if we fold it and then we will complete the folding, we will get that solid. It is the meaning of that folds and development. Development is actually cutting it across one of the slant edges or lateral edges or vertical edges. If it's a prism, it's a vertical edge. If it's a pyramid, it's a slant edge. Or if it's a cone, it's a generator. If it's a cylinder, again it's a generator. So we are going to open it and unfold it, and that the area that we get or the sheet of paper is called as development of lateral surfaces. So it has wide applications in many engineering areas, for construction purpose, for manufacturing of pipes or sheet metal components or textile components, or rather textile goods, and then tailoring industry. So many areas are there where it finds application. So let us learn about this concept in this session. We'll take case-to-case examples and understand the concept. First, let us learn about the development of pyramid. So the example is given for that of a square pyramid. The square pyramid with edge of base 60 mm and axis height 90 mm is standing on its base on HP with all of its base edges equally inclined to VP. Draw the projections and development of lateral surface of the pyramid. Now what is given is that it's a square pyramid, it's resting on its base on HP such that all of the base edges are equally inclined to VP. It means that they are making 45-degree angle with VP, and we have to draw the projections, and projections means in this case just front view and top view, and develop the lateral surface of the pyramid. So let us see this thing. We have already considered the projection part. So this is how the front view and top view of the pyramid will be. And now let us understand the concept of development of this pyramid on AutoCAD. See, we have this pyramid now. To develop it, we can cut it open from any of the slant edges. Either we can open it from OA, OB, OC or OD, any one. So let us open it from OA, or let us say we will open it from OA. So in this case, what is the slant edge length? See, OA is parallel to XY, so O dash, A dash is giving the true length of the slant edge. Also OC is parallel to XY, so O dash, C dash is giving the true length of the slant edge. So let us open it now. From this the method is like, you draw it separately first. So I open it with the object line only directly. I will copy this because this is the true length only. Okay, I will draw it alongside this front view, but it is not necessary that you draw alongside the front view. You can draw anywhere separately also. The important thing is that you have to consider the lengths only. Okay, so this length is the true length, and either you draw it separately or beside this, it's a matter of availability of space and your choice. Okay, but for betterment of understanding of the concept, or it is easier to transfer the points directly with using a drafter, so I draw it next to this front view. Okay, so I will draw it here as it is. So this is what is, I have replicated the slant edge here again, and now I will open it. So first I need to draw a circular arc. I do that with the projection line, arc of a circle, center, start and end. So this is the center, this is the start, and I draw it a little bit more. So I draw this arc, and now I will mark the base edges on this arc. Base edge length is given here as 60 mm. True length of the base edge is 60 mm. So we have 4 edges. So 4 times we will mark that length here. This is the first time. Again repeat this. Okay, I repeat this again. This is the second time, and third time now. This is the third time. This is the fourth time. So I have got these 4 times because there are 4 base edges. 1, 2, 3 and 4. Just join them. The last one with the last, and then the intermediate ones with the apex. And the base edges. So this is how we have got now. Suppose we open it from OA. So this will be our OA, and then the next B, C, D, and again A, because it is, we are tearing it and we are unfolding it. So this will come twice at the end also. And then when we want to make this solid, we will fold it along these fold lines and join it along this these two connected. So that is how the concept of development is utilized here. See, the naming is important here. The sign convention, the convention is that we use capital letters for the development. So OA, here A capital, that means that it is the fold in the development. OB, OC, OD and OA again. Okay. So this is the solution for this sum. Now let us take this another sum now. A square pyramid with edge of base 60 mm and axis height 90 mm is standing on its base on HP with two of its base edges parallel to VP. Draw the projections and development of lateral surface of the pyramid. Now it is almost similar to the first case, only the thing is that the pyramid is having its base edges, two of the base edges parallel to VP. Only that positioning is different. So we have already drawn these projections and we have discussed about these projections. Let us solve this in AutoCAD now. See, these are the two views of the given pyramid. Two of the base edges, that is AD and BC, they are parallel to VP. Now we have to develop this lateral surface for this pyramid. For that purpose, we will cut it open from one of the slant edges and then draw the development. The procedure is similar to the first sum. Now only the difference here is that you can see in the front view O dash, C dash or O dash, D dash. Are they giving the true length of the slant edge? You have to see the corresponding top views. OC is not parallel to XY. So O dash, C dash is not giving the true length of this slant edge. Similarly, OD is also not parallel to XY. So O dash, D dash is also not giving you the true length. Now you see these two, O dash, A dash or O dash, B dash. Here the top view OB or OA, they are not parallel to XY. So none of these slant edges are giving the true length in the front view. To get the true length of the slant edge, what we should do, we should use the concept of lines now. We will make them one of the slant edge parallel to XY in the top view and we will get the corresponding front view which will give us the true length of that slant edge. So let us do that now. Let us rotate OD and make it parallel. So let us draw a line here first, horizontally. And now let us rotate OD and make it parallel. Okay, so this we have rotated OD and now this is that we have made this parallel now. From this point we'll take the projections for the front view. So this is that point, we should join these two O dash. So this is that true length now in the front view. This is the line that we have got down. This is of true length of this slant edge because we have made this top view of this slant edge parallel to XY. So this is the front view giving you the true length of this slant edge. Now we will develop this lateral surface taking this as the true length. For that purpose, let us copy this or you can reproduce this. and we'll follow the same method now. Arc of a circle, center, start, and end. Okay, and then we will cut on the base edge length 4 times. $60 mm. So that way we will complete this development as like the previous sum now. Only the important difference was here getting this true length of this slant edge. Once we have got that, we will follow the same process. We will take now these base edges here and then join this with this O and complete the development part. So this is how we have completed now the remaining part for the development. The difference was here only getting the true length and then using that true length for drawing the development. That is the solution now. Let us see one few more sums. Let us see this now. A right circular cone of diameter 60 mm and axis height 70 mm is resting on its base on HP. Draw the projections and development of lateral surface of the cone. Now this is not a pyramid, it's a cone. So it will have all the curved surfaces. The lateral surfaces are curved and there are no edges on the lateral surfaces. The two views of this cone. So these are the two views of the cone. Now the thing is that we will open it from any of the generator. Now let's see OA. This is parallel to XY. So this O dash A dash is giving you the true length of this generator. Also OE is parallel to XY. So O dash A dash is giving you the true length of this generator. So we have directly got the true length of this generator. And we will open it from, let us say, OA and draw the development. For that purpose, when you cut it open from OA and develop it, what will be the base? It will be equal to the circumference, right? And then we will have all the generators in between. But the thing is that if you calculate exact circumference and then try to divide that into 8 parts, it will be time consuming act. So instead of doing that, we'll use some approximate method. That is, the length of the chord is equal to the length of the arc here, and then that is also valid. It is also saving the important time here. So let us draw this development now. For that purpose, I will copy this length. Okay, I will copy. I can copy it here adjacent, but now I will choose to copy somewhere else because this space is available with me. I will make use of this space. I have copied it here, and now let's complete this by drawing arc of a circle. Okay, so this is the arc of the circle we have drawn. Now length of the chord is equal to the length of the arc. That is what we are assuming. So what is the length of this chord? For that, you can find out when you are drawing it manually. You can directly measure that. It is showing 15. Again verify that. Yes, it is 15. Okay, so I will use this now. Something went wrong again. So this is one chord, let us say AB, and then we will draw around 8. We have divided this into 8 parts, so we have to draw this 8 times here over this. So we have got these 8 divisions here for the base. Now join them. Important thing is that we have to connect only the end generators with object line, because inside generators, they are not real edges, okay, they are just drawn for sake of construction, and that's the reason why no folding would be done over those generators. So no object lines for intermediate generators. And then this part of the circle. So this is how the development of the cone is drawn. And we follow the same naming convention that we had used. Capital letters for the development, OA, OB, OC, and again OA, in that way. The solution. Now let us take this. Write a circular cone of diameter 60 mm and axis height 70 mm is resting on its base on HP. It is being cut by a horizontal cutting plane which bisects the axis. Draw the projections and development of lateral surface of the cone. Now here the cone is standing on its base on HP and it is being cut by a horizontal cutting plane. Because of that, the top part is removed and we have to draw the development of this remaining cone. Okay, so let us draw that. See, we have already discussed in the first session on this content how to get this sectional view. So this has been drawn accordingly. Now we have to develop this cut cone. For that purpose, let us draw the development for the uncut cone and make the changes accordingly. This OE is parallel here to XY. So this slant edge is giving you the true length. O dash E dash is giving you the true length of this generator. Sorry, edge, it's not edge, it's a generator. And we have got the true length of the generator, so we will copy this directly. Okay, I will copy it here. Now I have got this positioning also, because I have copied it as it is, but when you draw manually you will mark these points location at this position and then develop this. Okay, now we will take the length of the chord is equal to length of the arc, that is approximate method. We will take that in the compass and go on marking it for 8 times for that base. See, we have marked it and also followed the nomenclature for naming it. So ABCD, we have assumed it to be open from OA, so OA is getting again repeated lastly. So this is how it has been opened now. And now we have, since we have got the positioning of these points at this level on the end generator, so that is already there. We will draw another circle, arc of a circle, and wherever this arc is intersecting with these generators, we will name those points here, P2 and P8, for example, P2 on OB, so OB P2, and P8 is on OH, so OH, we have got this P8 in this way. We have got these points on these respective generators in the development as well. Now connection is remaining because this already we have connected. Now this should be object line because that is the base, and again up to this level it is visible. Top portion is removed, so this portion is not shown with object line. So let us do that, show these object lines. So this is how we have drawn the development now. This part is there kept a retained part. So this is the development of that retained portion. This portion is removed. So that is removed because of the cutting plane. So this solution has been drawn. Now let us take this. A right circular cone of diameter 60 mm and axis height 70 mm is resting on its base on HP. It is being cut by an inclined cutting plane making 45-degree angle with the HP and perpendicular to the VP. That is AIP, 45 degrees angle. This plane passes through the point 15 mm above the base on the axis. Draw the projections and development of lateral surface of the cone. See, up to this projections part, we are already learned in the lecture 1 how to get this sectional view for this solid. Now in this session, we will add this development onto that portion. So let us see that on AutoCAD. See, we have drawn this development. This is that section part we have learned in the lecture 1. Now we have drawn this development without this cutting plane, considering the cutting plane. We are not considered the cutting plane. Now let us consider the cutting plane. OA, we have opened it from OA and got this development because the length of chord is length of arc. That is what is our assumption. Approximate method we have used here to get these segments or these markings on the base. So we have got this. We have used the naming convention, capital alphabets for the development. So this is how we have been doing it. Now let us see, if we open it from OA, this portion is already gone, so it is not existing, so there is no point. We should transfer this point P1 which is in between B and C, and just see that in this sequence we will draw the development from P1 completely up to P2. Okay, so this is what is required. So P1, to get the position of P1, take this distance B to P1, just measure that, how much is there, B to P1, distance B to P1, this arc distance is important. Huh? We are interested in distance of the arc, this chord. Arc distance is approximated as the distance of the chord. Distance is given as 8 mm. Okay, that is fine. You will see that it is same here between H and G for P2. H and P2. Okay, 8. You can see that the chord distance is 8. So it is same, either you start from this P2 or you start from P1. Let us go this way only. We have opened it from OA. So to mark P1 and P2, we will take that distance in compass. Say for example B. From B, we will mark this P1 center. Distance is 8 tap, and then you will see that you get this arc. This is the point P1. Similarly, between B and C we have got P1. Similarly, between H and G, from H, between H and G, from H we should mark P2. So this is how it is marked. And now once we have got these base points, we need to transfer the other points like P3, P4 also on this development. For that purpose, we will transfer it horizontally first on the end generator. Like P5 already we have got. So we'll take this distance O to P5. How much is this? Measure that. Distance O to P5, it is 42. Okay, 42. All right. And then we will project these points onto these end generators. Then O to P4. First let us transfer this 45 from O. 45. Okay, let us see that. This is for P5. So P5 is on OE. For P5, P5 is on OE. So this is a point P5. Now for P4 and P6, P4 and P6 at the same level, horizontally we have transferred it on the end generator. Now let us see this distance. From O to this line, this point, it is 46. Okay, you can see that it is showing 46. Okay, so let us transfer that here. 46 from the center, 46, and let us start that. This is for P4 on OD, OD, OD. So this is P4 and P6 on OF. So this is for this P6 on OF. Now P3 and P7 again we have transferred it here on the end generator. Let us measure that. The distance is 60. Distance is 60. Okay, so let us transfer that. Let us transfer that here from this O. Okay, that is for P3 and P7. P3 is on OC and OG P7. So this is done, and then that's all. P2 is on the base, P1 is on this base. So let us connect these points by a freehand smooth curve and then show that with object line. Alright, so we are joining them with the object line. This is only the development part. Rest of the lines are construction lines only because they are already not there. These are removed. Those part of the cone are removed, and when we fold this circularly, we will get this shape in the development for the lateral surface. Base part we are not developing. So we are only developing the side surface or the lateral surface, and this is how the solution for this sum. So this is the solution we have put up here on this slide. Now let us see one more sum and then finish your discussion. Right circular cone of diameter 40 mm and axis height 50 mm has its base in the HP. It is cut by auxiliary inclined plane which makes an angle of 45 degree to HP and passes through the point on the axis 20 mm below the apex. Draw the sectional top view, sectional side view, front view and true shape of the section. Develop the lateral surface of truncated cone. See, we have already done this part, front view, then top view, sectional side view. All this we have done in lecture 1. Now let us add this development of lateral surface to that solution, and that is the complete solution along with the development. See, this is the solution for that section part. We had already discussed this in lecture 1. Now development part. First let us draw the development of uncut cone. So this is a simple development. Now we have to transfer the various points from this cutting plane onto this development. The method is similar as like previous sum. We will transfer it first horizontally on this end generator because this is of the true length, and we will transfer these levers onto this end generator and draw the arcs, and accordingly go on marking the points. See, 15 first level for P1, for P2 and P8, 17, for P3 and P7, 22, 30, for P4 and P6, 30, and P5 it is 36. So we will mark all these things on this line. So first is 15, then 17, 22, 30 and 36. So 15, 17, 22, 30 and 36. Then 17, then 22, then 30, and finally 36. So we have got all those levels. Now we'll mark the points and name them. So we have got these points here and we have named them accordingly. Now joining of these points we will do these points like with the freehand curve, and then this portion, top portion which is being cut is removed. So this portion we will trim out of the development and complete the development. So we have joined these points with the freehand curve and then remove the top portion. So this is how the development of this cone which is being cut. This is the solution. This is the complete solution for this sum along with this section part. And that's all. I hope you understood these concepts. There are few more cutting planes. We will discuss them in other lectures if time permits. Till this thing, I think it is clear. If any doubt, we will always have this doubt solving session and clear those doubts. Thanks a lot for watching the sessions.